Hello, this is an experiment you'll be familiar with. You'll have done it in year 9 and year 12, and you're going to do it again in year 13. And it's investigating refraction through a rectangular glass block. Now, this is not an experiment you can probably do at home because you probably don't have a rectangular glass block and a ray box. So what we'll do is I'm going to complete the experiment for 8 incident rays, and we'll have a look at where the 8 emergent rays come out, and we'll be able to find the positions then of the 8 refracted rays. I'm going to plot out the positions of the rays. You can then print this out, plot the emergent rays, find the path of the refracted rays, and measure all the angles. If you do not have access to a printer, send me a message in Google Classroom and I will send you a completed sheet. And then we'll all be able to analyze the results together. So firstly, I'm going to draw around the glass block. The sides of the block aren't really important because we're only interested in the light that's going to travel in this top edge and out the bottom edge. Now, we don't want the light to hit in the middle. We want the light to hit somewhere around this direction. So I'm going to mark a position here. And we'll draw a normal at that point. I'm now going to mark the position of 8 incident rays. We're going to start off with an angle of incidence of 0, so in other words along the normal, and then we'll go on 10-degree increments from there. And I'm also going to draw the incident rays in at this point, just to save time later. As with any ray diagram, we should mark the position or the direction of travel of the rays. They're all going to be moving incident to the glass block. And I'm also going to number the rays so we know which one's which. So I'm going to replace the glass block as accurately as possible. Whenever you do this, you need to make sure that you don't accidentally skew the block. It has to line up nicely with your drawn lines. And we're going to mark the positions of the 8 emergent rays. I am just going to put little X's to show where they are. And when you print it out, you can complete the diagram. Be as precise as possible when lining up your ray with the drawn line, and place 2 X's, one close to the glass block, one further away, in the middle of the emergent ray. And I'm going to number these as I go along. Hopefully you noticed as we went along there was also a reflected ray along the top. We're just going to ignore that reflected ray. We're only interested in refraction. I'm going to take this away now. I'm going to scan it, and then we'll come back and have a look at how to complete the diagram. Okay, I've now scanned that. What we're going to do is we're going to complete the emergent rays. And one common mistake that's made is people join the 2 X's and leave it there. And so they get a line going there, and then bending the light at that point. Don't forget to continue right up until the glass block. That's quite tricky to do with a tripod in the way. So we've got our 8 emergent rays. We should have arrows really to show the direction that they're traveling in. We should also draw a normal at each point where they transition from light to air. So to draw the normal, I'm lining up the center of the protractor with this point of emergence, putting a mark 90 degrees from that, and then we'll draw those in afterwards. To do this accurately, make sure that you've got your 0 and your 180 degrees lined up on the block, and I'm putting a dot at 90 degrees above and below. And so if I've done this correctly, when I rule, I can rule from there to there. It should pass through that point of emergence and be as accurate as we can make it. Now we need to construct the path of refraction. The light was incident in the glass block at this point, and emerged at these points, so we can join this point to these 8 other points to show the refracted paths. What angles do we need to measure? Well, we need to measure the angles of incidence, and don't forget we always measure between the ray and the normal. So these are the angles that we'll measure. You should always mark with an arc an angle that you measure. Don't forget that our first angle of incidence is for this line. It's going to be 0 degrees. I also want you to measure the angles of refraction. And it's good practice to measure our angles of emergence. Not actually vital in this case, but I'd like you to do it. I'm also going to draw a results table here to show you what I'd like you to record. In our first column, our angle of incidence, and the unit is degrees. In our second column, we've got the angle of refraction in degrees. Thirdly, our angle of emergence in degrees. And we can do this for each of our 8 rays. I'll stop here. If possible, I'd like you to print out the scan that I've attached and complete this yourself and measure the angles. As I said, if you do not have access to a printer, send me a private message in Google Classroom and I will email you this with the angles measured so that you will have the results. Then we can follow the instructions to see what we're going to do.